This screencast is about a new section, section 4.5, integration by substitution. We're going to do just part 1 in this screencast about pattern recognition. Let's go back to the chain rule from chapter 2. Then we said that the derivative of a composite function is the derivative of the outer function times the derivative of the inner function. Here's an example of that. If y equals x squared plus 1 quantity squared, then its derivative would be 2 times x squared plus 1 times 2x. It's that n part that gets attached onto the end. So from the definition of an antiderivative, it would follow that we can just do that backwards. Somehow, I'm going to need to remove that g prime of x, though, the part that was attached to the end of the problem. So the derivative of the inside function needs to disappear and go away. So here, I want this to just completely disappear. This is the new pattern that we're looking for. Any integrals that have f prime and then g prime attached at the end will be a perfect candidate for being an integration by substitution problem. So let's start with this one as an example. Here in the chain rule, u was equal to x squared plus 1. So its derivative, u prime, is equal to 2x. I'm going to use a new notation, and instead of u prime, we'll use du. Du represents the derivative of u. So we're looking for that perfect derivative that was attached to the end of the problem. And you can see in the problem, it's right there at the end where it's supposed to be. This was attached because of the chain rule, so I'm going to go ahead and get rid of it and do the integration on the rest of the problem. The power rule says add 1 to the exponent and divide. So this answer will be x squared plus 1 quantity cubed all over 3 plus c. Here's another problem, very similar, but just a slight difference. Whenever we set this up for u and du, u is x squared plus 1, du is supposed to be 2x dx. But you'll notice we don't have a 2x dx at the back of the problem to go ahead and scratch out. There is an x, but it's in the wrong place. Now I can move that, so that's not a problem, but I'm missing the 2. Most integrands are going to have that variable part, but they're going to be missing the constant. When that happens, we're going to have to put it in there. So let's start this problem from scratch. And I'm going to go ahead and move that x to the back. So you'll see here it's listed at the end of the problem now. So just to remind you, u is equal to x squared plus 1. Du is supposed to be 2x dx. So I want to put a 2 back there. That's where it should have been in the first place. But in math, you can't just put numbers where you want them. We need to compensate for what we've done. So I put a 2 there. I'm going to compensate with a 1/2 in front. Now it's a perfect pattern. I'll get rid of that extra part at the end and go ahead and do the power rule. Add 1 to the exponent and divide. So I have x squared plus 1 cubed all over 3 plus c. To simplify, I can rewrite this all over top of 6 or a 1/6 in front. It's your own personal preference. Okay, let's look at another one. In this problem, u is 2x minus 1, so du is supposed to be 2. But there's absolutely nothing with a dx in this problem. Well, I can put the 2 in there. Just like before, I'll compensate with a 1/2 in front. Now it's ready to be integrated. I'll add 1 to the exponent and divide. So 2x minus 1 now has a 3/2 power divided by 3/2 plus c. Or after multiplying by the reciprocal, this will be 1/3 2x minus 1 to the 3/2 plus c. Okay, you try one next. Okay, here's the solution you should have gotten. U is 3x minus 1, du should have been 3. So after compensating for that, the answer is 1/15 3x minus 1 to the 5th plus c. Try another one. Okay, on this one, you needed to compensate with a 1/4 in front. We needed that perfect 4x cubed at the back of the problem. So after simplification and integration, 1/6 times x to the 4th minus 2 to the 3/2 plus c. Let's just do one last example together that looks a little bit different. In this one, it's actually a fraction. In calculus for integration, we don't have fraction problems, so don't worry, you don't have to do a quotient rule here. Instead, let's think about rewriting this. I'm going to move it up so that the denominator is becomes a negative 2 exponent. Notice how I put that x at the back of the problem. It looked like it was kind of going to be an issue being up there, but really it's all going to be part of the pattern, where u is 1 minus 2x squared, and du is supposed to be negative 4x dx. So I need a negative 4 back here, and a negative 1/4 in front. As soon as that's there, we'll get rid of it and start the integration process. I'm going to add 1 to the exponent and divide. So negative 1/4 1 minus 2x squared to the negative 1 all over negative 1 plus c. Or better yet, let me clean this up a little bit. The negatives cancel, and we'll get 1 all over top of 4 times 1 minus 2x squared to the first plus c. All right, so the key today is to look for that pattern. Anytime you see an integral where you have a composite function, so usually for us that at this point that means some sort of power rule with a derivative at the end attached, or at least it looks like it could be if you put the right number back there, it's going to be one of these integration by substitution problems.